Good afternoon, madam. My name is S. Nagarjuna. I am studying in Department of Civil Engineering in SRIT. Today, my presentation about on fixed beam for finding the deflection at the center of the beam. The question is, a fixed beam of 10 meters span carrying a uniform distributed load of 40 kilonewton meter run over 4 meters length. Starting from the left hand on concentrated load of 80 kilonewtons at a distance of 6 meters from the left hand, determine the moment at the supports deflection at the center of the beam. Take EI 15,000 kilonewton per meter square. In this, they have a given the fixed beam for a length of 10 meters and they are carrying a 40 kilonewton per meter from the left fixed end from 4 meters, and the concentrated load is from the left side of the fixed beam 80 kilonewtons. To determine the moments of the supports and deflection at the center of the beam. First, given data. Span length is equal to 10 meters. Uniformly distributed load 40 kilonewtons from the fixed end A. Point load P 80 kilonewtons at 6 meters from left end A. Flexular residue A is equal to 15,000 kilonewton per meter square. We have to find the moment at the support and deflection at the center of the beam. Here the figure of the fixed beam as shown in the diagram. Step 1. For finding the fixed moments, firstly, MAB is equal to formula is for the UDL from the left end minus WA square by 12L square into 6L square minus 8L square LA into 3A square, where A is the 4 meters, W is the 40 kilonewtons, and that's all. We substitute the values in the formula, that is equal to minus 40 into 4 square by 12 into 10 square, that of 6 into 10 square in 6 into 10 square minus 8 into 10 into 4 plus 3 into 4 square. MAB is equal to minus 174.93 kilonewton meter. Next, we find out the MBA. The formula for the UDL is WA cube by 12L square into 4L minus 3A, that is equal to 40 into 4 cube by 12 into 10 square, then 4 into 10 minus 3 into 4. The finding MBA is 59.33 kilonewton meter. Then next, MBC is equal to minus AB square by L square, where A is the 2 meters, B is the 4, L is the 6 meters, that is equal to minus 80 into 2 into 4 square by 6 square. MBC, that is equal to minus 71.11 kilonewton meter. MCB, WA square B L by L square, that is equal to 80 into 2 square into 4 by 6 square, that is equal to NCB is equal to 35.56 kilonewton meter. Now after finding the fixed end moments, we calculate the total fixed end moments of the beam. For MA is equal to minus 174. In this, to finding the total fixed end moments for the beam, we calculate the first MAB and MBC, that is MA is equal to minus 174.93 minus 71.11. MA is equal to minus 246.04. Then MBA means to calculate the MBA and MCB, that is equal to MB is equal to 59.33 plus 35.56, MB is equal to 94.89. To finding the deflection at the center, deflection is equal to WBX into L square minus B square into X square minus X square by 6CIL, where W is equal to 80 kilonewtons, L is equal to 10 meters, B is equal to 10 minus 6, that is equal to 4 meters, X is equal to 5, where delta is equal to 80 into 4 into 5 into 10 square minus 4 square minus 5 square by 6 into 15,000 into 10. Delta is equal to 94,400 by 9 lakhs. Delta is equal to 0.1049 meters. Delta is equal to 104.9 mm. Deflection at the center due to UDL. Delta full is equal to WL power 4 by 384 EI, that is equal to 40 into 10 to the power of by 384 into 15,000, that is equal to 0.1736 meters. To finding the for deflection of the UDL, that is equal to 0.25 into 0.1736, that is equal to 0.0434, that is equal to 43.4 mm. Total deflection at the center. Deflection total, that is equal to deflection at point load plus deflection at the UDL, that is equal to 104.9 plus 43.4. Deflection total is equal to 148.3 mm downwards. Final answer is fixed end moments. MA is equal to minus 246.04, MB is equal to 94.89. Second one is deflection at the center is deflection 148.3 mm downwards. Thank you, madam.